Good afternoon, everyone. Basically, appreciate your time and attendance. My name is TURAN. I am International Sales Manager at HIGHTEST Technology. Basically, we are just manufacturing transformer testing devices such as turn ratio, winding resistance, circuit breaker analyzers, circuit breaker timers, vacuum bottle testers, primary and secondary injection testers, contact resistance tester, and so on. Uh, Today, I'm going to a little bit talk about the protection systems in medium voltage and high voltage lines. And then I'm going to give you a brief information. I'm going to give you just a brief information about the protection system, main functions of the circuit breaker, which functions should be tested, key protection functions of relay, and then the relay testing, CT and VT as an instrument transformer, and then our solutions for all these kind of tests. Basically, it's we have a good solution for like all in one. First, we need to a little bit understand about the objective is to ensure reliable protection of high voltage lines. Basically, high voltage lines comes to our protection line, and one of our instrument is circuit breakers, and then we need to first focus on circuit breakers. What is circuit breaker, basically why we use this one, and then the function of circuit breaker. Basically, we use a circuit breaker on high voltage lines to safely and quickly interrupt the flow of the electricity during faults such as short circuits or overloads. It protects both equipment and personnel by isolating faulty sections, preventing damage, fire, or blackout. Main functions of a circuit breaker is circuit interruption, opens the circuit to interrupt current flow during the faults, causes it to resume normal operations, response to protection relay signals, operates based on trip signals received from the protection relays. It could be overcurrent, over voltage, under voltage, directional or frequency relays. Basically, a relay here is the given the orders to circuit breaker, and then circuit breaker just does the job. To be honest, in a simple way, if we just want to tell, fast and reliable action. Breaker operates within milliseconds to limit equipment damage and avoid cascading failures. And the fault isolation disconnects faulty sections of the power system to protect equipment and maintain system stability. Main functions of the circuit breaker. Basically, it is three-phase coordination, performs open-close combinations simultaneously across all three phases. Manual and automatic operation can be triggered automatically by relay or manually by the operators for the maintenance or test. Minimal energy cutoff time reduces the energy cutoff time by using open-close and or close-open functions. Which tests should be performed for the circuit breaker testing? We can just do the circuit breaker timing test, which is the most important one. Circuit breaker timing test. This test should be for three-phase simultaneously. We can make open, close, open, close, close, open, close, open in accordance with the ability of the circuit breaker. With the test results, we can examine three-phase timing results by comparing them with a manufacturer's specification, as well as the difference between the minimum and maximum timing of any phase. In here, in our test, our main criteria is the measured time, delta time, has to be smaller than 5 milliseconds for the 50 hertz and 4 milliseconds, smaller than 4 milliseconds for the 60 hertz, the quarter period of the signal. At the right side, you can just see one of the sample results for the three phase. Phase 1 is 42.3, phase 2 is 43.1, and phase 3 is 43 milliseconds. And the delta time, which is the difference between the higher and the lower timing, is 0.8 milliseconds, which is smaller than the 5 milliseconds, which is our delta time. So we can just say here that the test is passed and successful. And also at the circuit breakers, we need to do the contact resistance measurement. As an industry standards, we need to make a test at 100 amp DC, and results must be compared to manufacturer's specifications. Dynamic resistance measurement also we need to perform. This test evaluates the condition of the main contacts during the operation by measuring the resistance continuously while the breakers is opening, helping detect wear or damage not visible at the static resistance test. So as I said previously, circuit breaker is the guy who does the job, and it gets the order from relays. So relay is like decision maker. Relay is decide either the circuit breaker has to open or close or that kind of functions it has to do. So order just given by the relays to circuit breaker. That's why now we need to focus on a little bit the protection functions of relay. Basically, relay is overcurrent and earth fault protection. It supply detects excessive phase currents or ground fault currents and issue a trip to isolate the faulted sections according to its set values. Over voltage and under voltage protection. Again, the relay monitors line voltage extremes and trips on the sustained over voltage to protect insulation and on under voltage to guard against unstable operations. Directional fault protection uses phase angle comparison with the CT-VT input to determine fault direction and ensure correct breaker operations in meshed networks. And frequency protection trips on under or over frequency exertions to safeguard generators and loads during system imbalance. So how we test the functions of the relay? Overcurrent and earth fault protection. To test these, users should apply current directly or indirectly, while applying time should be kept, and according to contact, user should stop the current and duration of the trip time. Over voltage, under voltage protection. User should apply the voltage according to set values, keep the time while applying, and stop the current accordingly with the contact once the trip is done. Basically, we are just measuring the trip time for when we just testing the relays. Directional fault protection. Rather than applying the voltage, the current at the same time, user should set the angle between the voltage and the current in directional fault protection tests. And frequency protection, user applies the voltage accordingly at the different frequencies and observes whether the trip takes a place or not. Time should be kept as well. So this is basically how we measure, how we do the test for the relay as well. I am just try to explain in a very simple way. And yeah, as we said, the circuit breaker just receives the order from the relay, and relay is just decides that the circuit breaker open or close performance, and relay is getting the information from the voltage or current transformers in a protection system. So next slide, we are going to focus on VT and CT as an instrument for the transformers, current transformers and the voltage transformers. Current transformers function is to measure to current flow through the high voltage line, connect to each phase of the line, typically on either side of the breaker, and the relay is detects overcurrent, short circuit, ground faults, and direction of current flow, etc. For the voltage transformers function is step down the high voltage to safer level for the measurements, from the high voltage to certain level, let's say, and connected to line to ground or line to line voltage points. And relay is detects over voltage, under voltage, frequency changes, and the directions. Basically, relay is just using CT and VT to get information from the line. And if it detects anything, and then it just sends the orders to circuit breakers for the open or closing. So let's see our focus on so how we do these kind of tests. As a HIGHTEST technology, we have a unique solution for the protection test set. We have a single device. It performs all these tests. Basically, with our SUVI, you can test your relays, circuit breakers, and also CT, VT. You can do the contact resistance test, and also you can do the tone ratio test for the three-phase transformers. So in this part of my presentation, I am going to talk about a little bit our SUVI series. Basically, SUVI is a multifunctional test set. It can apply up to 110 amp AC, 120 amp DC, and the voltage output is 150 volt AC and 220 volt DC. Phase angle adjustable 0 to 360 degree. It has 4 contact inputs, 2 contact outputs, Ethernet communication, USB flash drive, and also you can see the menus here. Yeah, basically this is SUVI's menu. As I said, with the SUVI, we have a manual relay timing test, single phase CT, VT, PT, three-phase ratio test, circuit breaker timing. We can do the resistance measurements also. So it is like a total protection tester, let's say, in another word, especially for the cubicles. You can use just a single device. First, if you wish, we can just start with the relay timing. At the relay timing test, uh, as I said, you can just do the overcurrent, overvoltage, directional overcurrent, frequency controlled relays. You can apply 110 amp AC, 120 amp DC currents, and also you can apply 150 volt AC and 220 volt DC, and then you can just set your uh, internal or external connection. You are going to get your times. You can just choose your frequency. If you wish, you can just create your test table. Basically, it is very simple, easy device to use. And if you, yeah, if you can see, if you can do the test create, you can create a test table, and you can do the periodic tests as well. um, yeah, basically, you can see at the first line for the timing sign times for the currents. You can start with the 5 amp, 10 amp, 15 amp, 20 amp. You can continuously add another values, and then you can just measure the basically the time. Secondly, we need to test for the resistance measurement of the circuit breakers. Um, Again, you can just apply up to 120 amp DC. You can choose basically any amount. Measuring capacity of the device is up to 5 ohm, and with the minimum resolution is 0.001 micro ohm. You can add your test currents. You can add pass and fail criteria. Also, you can add temperature correction and dual ground feature. You can do the passive or active as well. And if you don't know how to do the connection, all our menus, we have a help section. If you press that one, also device is shows you how to do the connection to help the menu assist the user to understand how to do the connection, and also shows the connection diagram as well. So this is one of the sample test results. We just applied the 5 amp. Uh, Pass and fail criteria is passive. Temperature correction is passive. Dual ground is passive. And we can see the resistance at the first column and test current at the second column, and pass and fail criteria is pass, and we can also see the resistance correction as well. So the next one is our circuit breaker, which is main function of the protection. Basically, circuit breakers, we can do the circuit breaker timing test. We can perform open, close, open, close, close, open, open, close, open test simultaneously for the 3 phases. And the resolution of the circuit breaker test is 50 milliseconds, and initiate current measurements. We can also measure the bounce measurement, bounce counts, and then we can apply our trigger internally or externally. At the graphic, you can see the time window. You can choose basically 1 second, 10 seconds, or 20 seconds. And timing mode, you can choose open, close, close, open, close, open. And the trigger mode, also you can choose your internal or external trigger. Also, you can see here a help button. When you click that section, also device shows you your connection for the internal trigger, external trigger open, and external trigger close side. Basically, it just shows you how to do the connection as a diagrams. And here there's some sample test results. At the sample test, you can see the close time at the left-hand corner. You can see the cycle, you can see the bounce, 40 milliseconds, 60 milliseconds, and 110. And also you can see the bounce count as well. At the first phase, twice, the second phase twice, and at the third phase there are four bounces. Also, we can see at the graphic at the bounces, we can just enlarge it, or and we can see in better way at the top diagram. Basically, it gives you everything. uh, to be honest, the cycle, bounce, and the bounce time and bounce code. So we can just do the uh, circuit breaker time, and the delta time has to be, as we spoke previously, should be smaller than 5 milliseconds. At the first diagram, we can see that the delta time is only 2 milliseconds, which is under uh, our basically um, and I can see the bounces, and yeah, maximum current level, reset, and next results. So we can see the bounces here. Multifunctional test device. As we spoke earlier, the relay just decide open or closing according to information it gets from the CT or VT, depending on the protection system. Basically, we have a single phase CT test as well in our SUVI. For the current transformer, you can apply 1 volt or 4 volts, and the accuracy is 0.08. Phase angle measurement, you can see between 0 and 360 degrees. You can also see at the ratio error, and ratio measurement is up to 10,000 ratio. Again, we can see the connection diagram. The device is showing us how to do the connection between the CT and the device. And there is one sample test result at the right-hand side, which is the ratio. Supposed ratio is 19.85, and the percentage error is 0.72, which is pass for the for our calculation. Yeah, basically this is our CT test, and the second one is our VT and PT test that we need to focus on for the protection system test. For the VT and PT tests, we can apply a test voltage starting from 1 volt to 100 volts, 4 volts, 10 volts, 40 volts. The accuracy is again 0.08. Phase angle measurement, we can just perform ratio error calculation, ratio measurement, again up to 10,000 K. And we need to choose our primary site, secondary site, Also, we need to choose our test voltage. We need to choose the test frequency. We can activate the calculation error as well. And also the device is showing us how to do the connection with the transformer. And again, we have a sample test results here, which is pass. And also the last one is three-phase ratio test. Especially we use that for the cubicles as well, because inside the cubicles also there's a three-phase transformer that we can just do the test. For the three-phase ratio measurement, we need to enter the configuration of the transformer. For the primary side, if it's delta or star, and also we need to enter the configuration of the secondary side. We need to enter the vector group, and then we need to enter the primary side, secondary side. If there is any tab, we need to add that one as well. We need to decide our test voltage, and then also we can choose the test for the top priority or phase priority, and the test frequency as well. So again, the device is showing us how to do the connection for the three-phase transformer. In here, we can say the transformer is configuration of the transformer is DYN11. Our test voltage is 10 volt. Our test frequency is 50 hertz. Primary side is 36,000. Secondary side is 400, and the nominal ratio is 155.885. And we choose also top priority. At the second slide, we can see our test results, the expected one and the measured one, and we can see the phase difference and also percentage of error, basically. And also at the help button, we can see how we're gonna do the connection as well. So after finishing all these tests, it means that we just fully test for our protection system, basically relay, circuit breaker, timer, contact resistance, CTVT. Basically, we just done it all, and we can just see all our test results at the record site. We can see we can just save them one by one. Also, we can just do the screenshots, and we can see our test results as a screenshot as well as a picture, let's say. And we can just add the company details, manufacturer, and the test details, etc., etc. So basically, this is a brief information about how we test for the protection systems, why we need to test our protection systems. And thank you very much for your time, and appreciate your attendance.
Okay, thank you very much, Ethan. Good, thank you very much. Okay, so
Randy, for the question and answer, also we have our application engineer, Mr. Sadat, here. He has a great technical background as well. If you can unmute him, also he can
sorry,
just.
what's his name? Sorry, I'll look in the list.
Sadat, Mr. Sadat.
How do you spell that?
SEDAT.
Let me see. I don't see him in the list. I see Richard there. Richard's there on the list.
Oh, okay. I think he just entered with my name also. So I think, yeah, he is here. Can you hear us, Sedat?
Yes, yes, I'm here.
Oh, good.
Yeah,
Okay. Oh, yeah,
perfect.
you're there
Perfect.
twice.
Oh,
Sorry. Yeah, you're there twice. Okay,
yeah, he
so
just joined with my accounts.
that's great. One of the
Yeah.
questions here was how user friendly is this device for technicians who aren't familiar with advanced relay and breaker testing?
Yeah, I
It
mean,
seemed
basically,
the device seems user friendly, but that's the question. How user friendly is it? I mean, does it require training? That's another question. What kind of training or support do you offer new users adopting this system, this test equipment?
yeah, basically we can just supply them an online training, or if they wish to have a field training, we have partner in Canada, Power Source Instruments, and my friend Mark can give them a on field training as well. They are just based on Toronto, so they have a great field experience. They can just yeah, give them any kind of field training. But the thing is, as you said rightly, the device is really user friendly. When we just design it, we just mind that we are going to sell this device to basically uh, everywhere in the world. So most of the people is not going to know English. We're gonna sell the devices from Vietnam to Africa. You can just name it, and then we just mostly use for the symbols, and also devices asking for you for in each step what you want to do. You want to do relay test, you want to do circuit breaker test, or CT, so all you need to do is just follow the device. It's really easy to use. Yeah.
Okay, okay. Another point came out about calibration. What kind of calibration is required for this?
Basically, calibration issue is changing from country to country. Every country has their own standards, and every country has their approved laboratories. So when we send our devices, we just send them with the factory calibration, and some of the countries just requires calibration in every year. Some of the countries just requesting in every 2 years. Some of them every 3 years. So basically, this is just the calibration is done by the uh, country, current output, voltage output, and the resistance measurement. They can be all at the timing as well, is going to be calibrated by the approved laboratories.
Okay.
I'm
Uh,
sure that in Canada, there is a approved body who just gives approval for the calibration laboratories
right.
for Canada, and then all they need to do is just send these devices to for that kind of approved laboratories.
Okay.
It's very
Thanks.
easy to
So
do it.
yeah, what types of clients or industries are using this technology, using this device?
Yeah,
Are they
basically,
are they utility, industrial, commercial, institutional? Is it frontline electrical engineering maintenance people, or who is it?
yeah, I mean, mostly distribution utilities,
Mm-hmm.
uh, service companies, who just give servicing, maintenance, and testing for the that kind of utility companies. Yeah,
Mm-hmm.
mostly distribution and service companies.
All
But
right.
as a high test technology, also we are just manufacturing transformer testing devices for the distribution, transmission, transformer manufacturers, commissioning companies, and uh, basically the service companies, even laboratories are using our devices. globally.
Okay. Okay, great. One of the people wanted to ask you if you can go through a typical field application where your equipment significantly improves the testing efficiency and accuracy.
Yeah, I mean, basically, exactly. To be honest, the SUVI weighs only 9 kg. With the
Yeah.
single device, as I said, you can perform all these 4 tests. Like you can test your relays, circuit breaker, and your CT, VT. You can do the turn ratio, 3-phase turn ratio test as well. So it is very time consuming, and basically you can just do full test with one device. So yeah, I mean it's in terms of time efficiency and really easy to use device. I mean the connections also really simple. Once you go there, let's say for the cubicles, you can just test your circuit breakers, relays, CT, VT. Yeah, I mean it's very simple, very easy, very time consuming.